the arrow indicates on the line there that the line goes on. So basically, it means that it goes on indefinitely in both directions. Okay, that's a line. So that's how you would write the line. Now, these two lines, they're called parallel lines, and they are in the same plane. So basically, they're in the same area, but they never cross each other because they're always the same distance apart. So this is heading on this plane, this is heading on its own plane, but they're never going to cross. So just like these two pieces of spaghetti, right?
Yeah.
Now, what about intersecting lines? Intersecting lines are lines that do cross. So it's like this. If this spaghetti stick was going in this direction, it was headed, eventually the line, remember, it goes indefinitely. So the line will eventually cross this line. And right there where they cross, that is called a point of intersection because that's where they meet. The two lines meet. Okay?
Yeah.
So they may have one point in common, which these two sticks of spaghetti do, these two pieces of spaghetti do. They have one point in common. That's the point where they meet or where they intersect. Or they can have all points in common. Now, if they have all points in common, how can that happen? All points in common, that means they're becoming one line.
Mm-hmm.
That'll be the only way for them to have all points in common. Okay? Great work. So let's move on to our illustration of the intersecting points. Okay, so we started with the one spaghetti, right?
Yeah.
And how many intersecting points do we have?
One.
How many points of intersection do we have? None, because there's nothing meeting. There's nothing intersecting. And then when we did two lines, we kind of drew them like this. And what do we call these lines?
We call them parallel.
Parallel lines. Very good. Do they intersect at all?
No, they
No,
don't.
they don't meet. They're not meeting each other. It's like this person's going their way and this person's going their way. They never meet each other, right? Good job. Let's add another piece of spaghetti. I have a big box of spaghetti here. Let's add a third piece. Arrange it however you want. Okay, great. So now, how many? Well, let's go back. Let's take the third one off. Let's rearrange the two sticks of spaghetti first so that they meet, that they cross each other. Okay, and X. Okay, let's draw that figure down here. Take your pencil. Sorry. Draw that figure. Wait, first of all, how many points of intersection do we have?
One.
One. So we'll go to the two spaghetti line and we'll go to the box that has one point of intersection and we'll draw this diagram in that box, just like how you have it there. Good job remembering your arrows there, which means that those lines are going to go indefinitely in any direction, right?
Yeah.
Good job. Now, let's include our third stick of spaghetti. Put your pencil there. Any way you want to. Great work. Almost like a star. You want to change it?
Mm-hmm.
Where do you want to go? How do you want to put it? That's good to show that, yeah. And that way you can show different points of intersection. Now, how many points of intersection do you have now?
We have three.
Great. Can you point to them with your pencil?
1, 2, and the third one is in the middle.
Right. So that means that the lines are meeting in three different places, right?
Yes.
Very good. So on here, we're going to show, nope, got to go to the three spaghetti line. Remember? Three. So how many points of intersection do you have? How many points of intersection do you have?
3 points.
So you have three spaghetti. Right. Good. Right box. Great. Again, good job including those arrows, which means that the lines are going indefinitely in those directions,
And
right?
they can go far.
farther, of course. This is where our line stops, where our eyes stop seeing it. But a line can keep going in that direction. Very good. Okay, let's get another thin piece of spaghetti. Arrange it however you want. You got 4 pieces. It kind of looks like tic-tac-toe. Let's play a game of tic-tac-toe. I'm X. Hold it. You can go first, Steph. Ah, you got me. You beat me.
Tic-tac-toe, 3 in a row.
Okay. Very good. All right. So now we have, how many sticks now do we have?
We have 5.
Oh, wait. We got to take one off. Let's go to 4. Okay, good. Now, how many points of intersection do you have now?
We have 4.
4. Okay. So let's write this tic-tac-toe diagram in the 4 lines. Yep. In box with 4 points of intersection. Good. Very good. Okay, let's add the 5th. The 5th spaghetti. You gotta rub it in my face that you won, huh? Good job. Now, how many points of intersection do we have now?
We have 4, 5, and 6.
6 points of intersection. Very good. This is a question mark, so just write it down right. Because you can make it 6. Okay. You don't have to include the arrows. There's so many. Because if I were to take this 5th stick and do something like this, now I have even more points of intersection. 1, 2, 3, 4, 5, 6, 7. So that's why there's question marks there, because you can turn the sticks in whatever arrangements you want, and you can have so many points of intersection that it can be indefinite. So that's why the number is a question mark. Very good job. I had a question that was in the book, and it said, if you have 2 sticks, right, 2 sticks of spaghetti, and they are crossing here, can there be 2 points of intersection on between these 2 sticks of spaghetti?
No, there can't.
Why not?
Because there's only 2 pieces of spaghetti, and if you want to do that, that can't work because there's only 2 pieces, so you're gonna have to do that.
Right. So we can't
do
curve it. Oh, that's exactly what will happen. We can't bend the line. It has to remain in that direction. And that's exactly why only 1 point of intersection can be accomplished between 2 sticks of spaghetti. Great work, Gabrielle. What a great job you did over here in this paper.